Welcome back to the Torque Test channel. This is a Milwaukee 1-inch pistol impact that we bought solely for this episode because no used ones were available at the time. Please forgive me because this is a DeWALT 60 volt 20-inch chainsaw, the most powerful one they make, that they rate at 4 horsepower with the right battery, and boy do we have the right battery. One of the most powerful cordless chainsaws you can buy, and the future heart of this Milwaukee impact wrench. Let me explain. The old M18 2867, she's a sweet unit, but the thing is, only in forward really, for like metal workers, bridge building I guess. In reverse, the own brand's half-inch impact wrenches now eclipse it, which I think is a bit sad for a $800 impact. And to pour salt on the wound, DeWalt's latest beast, the DCF 961 with VTEC, can even beat it in any direction in the numbers, meaning these days a $370 DeWalt half-inch tops a $800 red 1-inch impact. And until Milwaukee rectifies that sort of thing, we're willing to play God and make it happen in the most abomination-like way possible. You see, the problem really is though, no one or very few advertise cordless saw RPM, like the actual revolutions per minute, because why would they? We bought this here DeWalt to basically find out, and the answer is 7,000 RPM. Now that in itself is both too slow and too fast to work with at the same time. The motor inside this Milwaukee spins 20,000 RPM happily. That's because it has a planetary gear set that reduces that down by a lot, all the way down to 1,650 RPM. It does this to be able to spin up this large hammer mass up front and drive the reset spring over and over. Now it may seem counterintuitive, but the recipe for more torque on these things is usually speed, because in delivering that torque, instead of like a hand crank, it's working like a hammer. And the way to increase the hit from a hammer is size, mass, which is sort of baked into the tool and spring design, and speed. Now speed, that's something we can do, but maybe not 7,000 RPMs. So that's why we're using the old TTC lathe here and some custom 3D printed brackets by Logan from our TTC Skunkworks team to mill some parts. And this is to adapt the 60 volt DeWalt chainsaw to our own planetary gear reducer, a bigger, beefier one of our gear reduction choosing. This is because the 7,000 RPM plugged into the M18's gearbox would be a snail's pace with that type of gear reduction. Plenty of motor torque behind it, but no slap happy fun. So we went with a 3-to-1 reducer made for stepper motors, but we think it's made for lower RPM, higher torque CNC stepper motors because it was packed with grease, which was replaced here with gear oil for a more free spinning, low drag, max beans sort of setup. This turns the chainsaw from 7,000 down to 2,330 RPM, which when adapted to the Milwaukee impact means a straight up increase from 1,650 to 2,333 RPM and 2,450 IPM up to theoretically around 3,300 impacts per minute at a higher velocity, meaning a bigger boom, or maybe just boom. So with some custom broaching for a new keyweight shaft directly into the heart of this 1-inch Milwaukee, Logan performed surgery on the whole mess of mass and transformed it into the Chainsaw Massacre you see before you. This thing is designed to chooch in reverse, something the current red tool doesn't do all that well. So by turning a 1-inch grade 8 bolt tight with various levels, Logan was able to assess if the Chainsaw Massacre was fit for prime time. And that's easy stuff. Here's with a maxed out torque wrench and red Loctite to remove. Still doesn't even notice it. Here's a fix with an impact wrench. Still not quite my tempo, and the bracket for the bolt has died now, so time for the vise. And this is just with that 1-inch thread grade 8 bolt having welds on the backside that the impact will have to try and pull through the 1.5-inch hex nut. Good luck, buddy. So yeah, Chainsaw Massacre 1, Harbor Freight Vice 0. And a big 0 for the grade 8 1-inch thread bolt and nut as well, completely nuked that thing. Can't say I've ever seen that happen to a bolt of this size with any impact that we've tested. Time for the main show. This is a 5-second test on the old dyno. Here's the M18 2867 with the biggest and baddest from DeWALT also on screen. "725 foot-pounds of torque over 651. It is a beast in forward. And here's the Chainsaw Massacre with a 6 amp hour battery, or effectively a 2 amp hour battery at the native 60 volts of this chainsaw. $925. Dang, and just listen to this thing. It sounds like an A10 Warthog. Yeah, this one's in a hurry for some punishment. And you'll notice this was run in reverse here. That's because, well, chainsaws, they tend to spin in one direction. We chose reverse because that's this Milwaukee's weak point. But once you choose, you're sort of locked into that. But locked into this amount of beans we're not, or potentially not. Here's that same 5-second test with a 9 amp hour flex volt, or 3 amp hours at 60 volt. Let's see if we can move the needle at all, as it has wider implications if we can. $977. Nice. This is good news, not just because of more sauce, that is satisfying, but it means we're actually taxing this chainsaw. When you build something like this, you risk on one end spinning, trying to hammer away so fast that you find out you didn't use a motor that can keep up with that type of task, or on the other end, gearing down so much with that output speed to the point where the motor, or chainsaw in this case, doesn't even notice it's being asked to do anything. But we're not done. DeWALT rates this chainsaw at 4 horsepower with a 15 amp hour battery. I've not seen them call out a power figure based on using one of these before, but we're here for it. Supersize me. One thousand and 36 in a 5-second test. Damn, cresting the 1K mark and just embarrassing all the established brands out there, am I right? I mean, look at how compact and ergonomic this package is. Who wouldn't want to use one of these on the daily? That's a TTC Skunkworks record, including gas-powered impacts with nitrous, gas chainsaws swapped onto railroad impacts, thanks in large part to impacts per minute. But hey, we're taking the W on this one today. What's going to have to take an L for now is our dyno. Yeah, she's not cut out for 10 seconds plus if we're already cresting 1,000 foot-pounds in 5 seconds. This thing's more rated for 1,250 or so, but above 1,150, the data starts to become worse and worse as that bolt stretches. But fear not, we got this massive Skidmore here, ready to take all the beans, no problem. This is, however, a forward Skidmore torque machine, so no way to tighten things up in reverse like on our dyno. So we'll need to tighten up this nut first, then run her on the dyno in a removing style dyno graph that we've done before with cordless 1-inch impacts and have that data to compare to. As for the stock M18 1-inch 2867, that one's goose is cooked, I'm afraid. Yeah, spoiler alert, we've already in a 5-second test eclipsed the most it ever made for us in forward or reverse, which would be forward here, 1,036 foot-pounds versus 1,020. No other higher numbers to show you with this one, so we must move on to bigger and badder things for the Chainsaw Massacre to take on. And that's this M18 1-inch D-handle for some red on red and yellow crime. Let's see them head to head, removing over 1,000 foot-pounds here. The gauge display multiplier is times 1.31 on this one for you data nerds. Okay, so yeah, maybe not a $1,000 M18 1-inch D-handle levels of torque in what we've made so far. We are, after all, limited by that hammer size up front, but both did take it off. The next bit is removing over 1,400 foot-pounds up against the red D-handle, and this is where things start to go a bit pear-shaped. Yeah, this guy wasn't named the Chainsaw Massacre for nothing. In this run, it just killed about everything. Stripped the last remaining bolt out of the head here, began smoking profusely out of a tool that doesn't even contain motor electronics anymore, so that's an achievement in itself. The hammer and anvil fused together in a sort of half-overlapped way, real good. This took a bearing puller to remove, and the alignment shaft now looks pretty chewed up. That fusing together of things versus the socket with several hundred foot-pounds to go meant something was bound to break even further, and the press-fit machined input shaft we had here sheared its welds. But we haven't even shot the high speed yet of how this hammer's faring with that new heart transplant, so we polished up this anvil alignment, repaired the input shaft, and tapped new larger bolts into the head of this guy for the support bracket. And what we learned was this: the spring on the hammer is maybe just too weak sauce to be overclocked this hard. Not a new phenomenon for us on this channel, and this is made worse with an open nose cover shot like this because it's not being all kept snug together. You need to push forward with it, but the hammer would spin so fast that the anvil dogs would just over-rotate past and hit the next to be pinched down on that nose cover and land on the hammer face as that hammer returns from the spring force. That pinching happening many times resulted in the input shaft breaking and then seizing the bearing, which causes all this smoke. But really though, what we haven't discussed yet, and what we didn't realize until measuring it later, is the hammer assembly on this 1-inch M18, it's 3.06 pounds, 3 pounds 1 ounce, which is heavy, especially with the 1.1 pound massive anvil as a partner. But the DeWALT DCF 961 we're trying to eclipse here by any means possible, that one's hammer is just about 3 pounds 2 ounces, so the half-inch DeWALT these days is sporting more potential than the twice the price Milwaukee 1-inch. Damn, that is a bit embarrassing. Which is why we had to obliterate it today in performance with our own Mad Science Red version, with the help of the DeWALT, again of course, which then obliterated the whole tool. Not sure what the scoreboard really looks like anymore, but I think we're all the winners here today. Rarely do we need much of a reason to make anything stupid and potentially dangerous make this much power, until it doesn't.
Let's send it.
Appreciate you joining us for this one. We make episodes at least every Friday. Click buttons to make the algorithm go burr. Thanks for watching.